So guys, today we would be doing the operations on rock paper scissor dataset. So if you are thinking what is this dataset, so I would be linking the link to the Kaggle website where the dataset has got its whole evaluation and data. So in this dataset, basically you have got a set of dataset which has rock paper and scissors, and from here you will get a lot and lot of images which consist of people pointing their hands in the form of rock papers and scissors. uh, here you can see I am using the Lawrence Mooney's blog app spot. He is the AI lead of Google, so I have imported the dataset from there. Now coming down, after importing the dataset, the first one more thing I want to tell here, that this is most probably going to be the one of the last thing in computer vision basics. Maybe in advanced things we would be doing in future, but coming to the beginners flow, this is the last thing, the last project we are making. So here we are importing OS and zip file, and from here we are defining the paths to our the datas, that is the test and validation data set. And going down here we are defining all the things, that how many images does it contain. So the training images of rock paper scissors, all three are 840 each. So the data set would be training on that. And if you want to see what these images are named like, it's like rock 2, like these images are named like this. So yeah, so we are going to check on this data only. And if you want to see how these images, I have used the matplotlib image, and here you can see the types of images that are, it's good that they have used all colors of hands, that is not being racial, because diversity is what Google developers and TensorFlow is all about, making things easy for AI and making all everyone equal in the vision. So here you can see we are importing TensorFlow STF, importing Keras processing, we are importing images data generator. As usual, we are doing defining training directory, then validation directory using image data generator, width shift, height shift. So make it a habit that you go to image data generator website of Keras and you see how many features available and which features you need to apply. These are not all the features, but yeah, these are one of the main features which everyone should use to make their model more nice. So here you can see I have, as usual, done training data gen flow from directory. We have been doing this from, I guess, past 3 more to 4 models, so you must have got an idea that we need to do these all things every time. So we are defining the model here, that is tf.keras.models.sequential, that how the model would be looking like and what it would be doing, the convolutional neural network. So we are putting up 4 layers of 4 layers above the model. The functions we would be using all here would be ReLU, and then the 512 neuron hidden layer. So this is how our model is going to be working on. And then we would be printing the model summary. So if you want to see the model summary every time, you can see it here. Okay, yeah, you can see 1 2 3 4 5 6. It means the last layer I'm counting that 2, and hidden layers 2. So yeah, it's working like that. And after we have seen the model summary, what we do every time, we do model.compile. Now why I'm not using binary entropy here, I told you last time, because we are not doing two things here, we are doing over three things at that time. This is used, and optimizer you can use Adam as well. I am using RMS prop, and then model.fit, and then we would be saving the model. Why we are saving the model? The point is that, see, you need to save the model because suppose at sometime in future you want to test how your model is going to work, you won't be doing the whole model again. Just simply save the model and call it whenever you in future you want to use it. Model.save is used in TensorFlow developer exam also, because they are you save your model, and then the model would be used by the compiler of TensorFlow to check that how your model is performing on datasets. And then coming to the next part is seeing how the model works. So here you can see the training accuracy and validation accuracy. The training accuracy is pretty high, going from down, and validation accuracy is also going good in this figure. If you want to see exact results, I would take you up here. You can see 95% on training accuracy, and oh, it's 100% on on the validation accuracy. That's kind of overfitting because you can see the vast jump. But yeah, sometimes it happens. Usually it's never 100%, but yeah, maybe the dataset here is so nicely represented that yeah. So now I would be putting some images in the dataset. Here you can see why how we are able to do that. So yeah, here I would just show you what images I have in the download section. I've got few images, that is paper and just like scissors and rocks, how these images look like. And yeah, you can see this is how I would be predicting the images. Yeah, so here I would go, I would just run this cell and it would be asking for some image. I would be choosing the files, and here I go, I have choose these 1 2 3 4 5 6 files. And let's see how well does the model perform here. So it's getting uploaded. While it's getting uploaded, let's revise the whole content. What we did, we loaded the data set, we prepared our model. If you want to use here the pre-trained model, you can experiment it here, because you know we did it last time, and you can get a practice here by doing that. So yeah, images have got uploaded. So yeah, you can see here the saving that. So we did like rock paper scissors. So both of these are third one is scissor, middle one is rock, and first one is paper. So out of 1 2 3 4 5 6, 5 out of 6 images are labeled correctly, because scissors here both are labeled scissor, rock here both are labeled rocks, but paper here one is labeled paper but another one is labeled rock. So 5 by 6 accuracy, that is I guess around 95% around around accuracy is being given here. So yeah, it's pretty good for me now. If you test it on a large data, you would see that yeah, it's working nice. So so this is how the model works, and this was how you can experiment with the rock paper scissors dataset. There are a lot of datasets. I would make a separate video on TensorFlow datasets and Keras datasets if in future too, where you can get the idea about how we can use datasets and experiment it on a machine learning models using TensorFlow. So this was it for the video. We experimented with rock paper scissors dataset. I would suggest you to experiment it with some pre-trained models. It's going to be nice. So thank you and have a nice day.